So the what is the complexity now? The complexity is logarithmic, right? So the big O term, this is of O of log of n, or you can say logarithmic complexity, right? So now the logarithmic in question could be, okay, uh, with logarithms we know that logarithm works on base. They have a base of 2 or 10 or 5, whatever you want to give them. They work on base. So normally when you are working with your calculators, the base of the logarithm is 10. But in computer science or in binary search or in these kind of search, we assume that the base is 2, right? To know more about logarithm, if you are not familiar or you need to refresh your understanding of logarithm, because you must have learned about algorithm in your school life, but as for those who are not who want to refresh their mind, they can use this link mathsfun.com/algebra slash logarithmic logarithms.html, or also they can view the Khan Academy's video, which is very helpful to you. So the complexity of this method, or you can say this problem, is logarithmic complexity of n complexity. Okay, so the big O analysis. So the big O can be used to determine 3 cases with an algorithm, right? Base case, worst case, average case, and a worst case. The best case is, in telephone book search, the best case is that we find the name in one comparison, that is O of 1, which is called constant complexity, which we did, right? When we tried to find Muhammad, in that case we just found our required result in one step. We didn't uh, divided the input size into 2. So this is the best case. In the worst case is when you keep on searching the list and you go to the you keep on finding this in the list, and you go till it lasts. So here let me say, if I want to take the logarithm of 26 and say log of 26, what will be the log of 26 with the base 2 here, right? So the base is so the base is so the base will be 2, right? Log with the base 2 of 26, if you search it, you will get 4, and we did the 4 steps. So this is the worst case, right? This is the worst case, in which we search till the last, and this was the best case, in which in just first comparison we got our answer. And if there is a name in which we do 2 steps, okay, the number of steps will be 2, that will be the average case. So for finding Qasim, the best case will be 1, but the worst and average case, but best case and worst case and average case will be 4. So for Muhammad, the best the worst case is 1, the best case is 1, and the average case is 1, right? So we have the log of n complexity, and in that we search our required result using 4 steps. Okay, now let's quickly just recap what we did. In addition we have log of n, linear complexity, and there is no subtraction algorithm, because addition algorithm has same complexity, right? so the addition and subtraction, they work on the same rules. That's why they both have O of n complexity. Okay, so for multiplication we have O of n square, or the quadratic complexity, and for division we have logarithmic complexity, right? Now here's another a problem, which is a traveling salesman problem. It's a very famous problem in computer science, and it deserves a mention. So what happens in this problem, you have n towns. Each of those towns is linked to one or more towns by road of a certain distance. The traveling salesman problem is to find the shortest tour that visits every town. So the problem here is something like this one. You have three towns, like we have three towns A, B, and C, and a salesman is there to do his work. He wants to know that what will be the shortest path from point A to point B, or you can say point 1 to point 2, or from point A to point C. So we have the total combination A, B, C, A, B, and C. We have ACB, we have BCA. These are the total number of combinations, and the total combinations we have is 6. So if we have 3 elements, or we have 3 points, the total number of combinations we can make is 6. If we have 4 points or towns, you can say, then how many number of combinations will be? You need to think about it, right? Okay, so don't do that right now, just be with me. So 4 towns, you have 24 possibilities. With 5 you have 60, and with 6 it is 360. So this function of mathematical operation is called factorial, right? So what is a factorial is, and the complexity is n factorial. So here the input size is 3. If we have 4, so the input size is 4. If we have 5 towns, then the input size will be 5. As you getting it that I'm increasing the input size. Okay, so 3 factorial is something 3 into 2 into 1, which is 6. 4 factorial is 4 into 3 into 2 into 1, 24. And 5 factorial is 5 into 4 into 3 into 2 into 1. So if we have 25 towns, then the result will be this big. And we have 50, and this tends to about 64. It's too big, right? So the big O of TSP, traveling sales person, it should be TSM, traveling salesman, right? By the time you get to 200 towns, there isn't enough time left in the universe to solve the problem with traditional computers. You cannot solve this problem with traditional computers with 200 towns. So the big O of traveling salesman problem is n factorial, or you can say factorial complexity, or combinatorial complexity. So I hope with these examples you must have got a better understanding of big O notation and the complexity, how we measure it, and how we represent our complexities with the help of simple example, with the help of simple addition, subtraction, multiplication, and division, right? In the next, so now it's just a review. We have O of 1, which is constant. O of n, if we are going through every step, right? If we have like n value is 10, then we will keep on searching, or we will keep on doing our addition or swiping, or whatever operation we are doing. The number of steps is 10 also. The number of steps is equal to the input size, then we call it the n, right? If number of steps we are going to compute our logic is log of that number, then we will call the logarithmic. And I forgot to mention one here. One is O of n square. right, square. So if the input size is 10, then the number of computations we need to do will be 10 multiplied by 10, and that is 100, right? Here the number of computations will be equal to the input size, and in log, if we have 26 as a number, then the number of computations we need to do is maximum 4. In factorial, if we have 5 as input size, the complexity will be I forgot, 120, right? The number of computations will be 120. So in the next lectures we will see the code, that how we can compute the complexity while looking at the code, how the code can give us the complexity of an of a program, how we can measure the code's complexity. It's actually the code which gives you the complexity. So I hope you must have got an idea by now, or you must have understood this, the big O, or the big O issues, or you can say the big O problem. It's one of the toughest for the computer science students, especially for the new students, and I hope I tried my best to deliver this with simple examples. So thank you for watching, and we'll see the codes in the next lecture.